Hey everyone, welcome to Cloud Masters. I'm your host, Matan Bordeaux. I'm joined by my co-host, Sam Clark. And we have AWS subject matter expert, Swapnil, here to join us and basically explain what is all this fuss about this new release at reInvent, Amazon S3 tables. Welcome, Swapnil. Maybe we can kick off because I know there's S3 buckets, and I know with the introduction of S3 tables, which you can kind of explain what that is, there's also now S3 table buckets. So maybe you can demystify that for us. What are the differences and whatnot? But welcome.
Cool. Thank you for having me. So just to put it in single line, S3 bucket is primarily for your cloud storage solution. But when it comes to S3 bucket tables, it gives you an optimized way of storing Apache Iceberg tables. And it's just an extension of S3, but you can store your tables at scale in Iceberg format. And everything is done automatically for you. Your Iceberg table maintenance, your storage, everything is automatic. So it's more like a managed Iceberg storage backed by the advantages of Amazon S3.
You mentioned Apache Iceberg. Now, I'm familiar with Parquet and use that a lot with things like the custom user reports and stuff. Amazon provides those in a Parquet format. What's the difference with Parquet and Iceberg?
So there are two different technologies. Parquet, in a simple term, it's just a file format. But the good thing about Parquet is it gives you improved storage, and it is really highly recommended for faster query performances with your big data solutions, analytics solutions. What Iceberg does is extends the capabilities of Parquet. It uses Parquet as the underlying data, but with Iceberg, it gives you more like a database-like capability, meaning it gives you ACID transactions, it gives you schema evaluation, it allows you to time travel as well. So, I can go back in time, let's say, 1st of January, what was my sales amount and things like that. So this is not possible when it comes to any of the data format. You cannot do updates, inserts, deletes on your data in S3. You have to write a new data altogether. And that is what Iceberg allows you to do. You can just do multiple updates to your data, and that's the added advantage. It basically gives you ACID-like transactions.
And from what I understand, the difference here between the bucket, S3 buckets and the table buckets also is that you don't have to basically manage the storage yourself or maintain the table.
Exactly. You don't have to manage the table or even manage the Iceberg optimization job. It's automatically done for you by S3 tables.
And so my follow-up question to that is, before this existed, what challenges did teams typically face when they're trying to maintain these Apache Iceberg tables at scale? And maybe if there's anything more to elaborate on how S3 tables addresses it, besides, it does it automatically, but maybe you can take us back to what was even the reason that Amazon decided, hey, we need this, we should build this.
Got it. Okay. So this is going to be a long one. So back in 2006, if I'm not wrong, Amazon introduced Amazon S3, which is like a storage solution. And primarily, as we all know, is a cloud-based storage solution. That's it. But over the years, with big data, AI, machine learning space, lots of the solution started using S3 as the data storage for obvious reasons with scalability, durability. And then during this time, it was an advent of open table formats, meaning you can write your data in file format which you prefer. It can be as simple as a text format, CSV, things like that. But for big data, data analytics, machine learning, you need something better. So you have column level formats coming in, which is Parquet, your Avro format, ORC, if I'm not wrong. So these are multiple column level formats to query efficiently your data. But again, when these went at scale, you were not able to perform your updates and things like that. Let's say I want to update my sales data for a particular customer. I have to rewrite the whole data again. S3 doesn't give you that capability to update my record or do frequent inserts. Imagine I'm having a streaming data that is doing frequent inserts, updates, deletes to my data. That was not possible in my Parquet data, right? And that is where Iceberg came into picture. It got very popular, as you know now. So it uses Parquet as a file format, but more in with Iceberg is that everything is done automatically. The only, I won't say downside, but with Iceberg, you will need to look after your table maintenance, meaning that the frequent updates that were coming in, they will write small files, and having too many small files is not good for your big data analytics. And that's the reason you will need to manually or automatically somehow look after your compaction of that small files, your snapshot management, your unreferenced files. There are a lot of unreferenced files that stay in your data set because of that frequent updates. And so this added that extra overhead management to look after these many factors when it came to Iceberg at scale, and to address everything in and do it as a fully managed service. That's what S3 table does for you. So you just say that, okay, this is my S3 table with Iceberg format, and the same problems I specified of my table maintenance, compaction, everything is done automatically for me at the back end.
Can we take a deeper dive into those maintenance operations? So, is compaction a new word for it? Is that a key term, a new term to learn for if you're exploring this, or was this already a term familiar if you're working in databases or working with S3? You mentioned compaction, snapshots, and unreferenced files, I think.
Yes. So these are the three terms, or these are the three maintenance job when it comes to Apache Iceberg. So this is Apache Iceberg specific terms. And namely, I'll go over one by one. So let's start with compaction. So when you have frequent updates to your data, you will have too many small files that will be written to your S3 data, and that is not good. So with compaction job, you can specify, what size of the file you want. So that too many small files will be compacted into one big file of optimum size. And when I say optimum size, ideally it will be around 128 MB, more than that, for your faster query performance. So there will be frequent compaction job that will be running at the backend for you, to compact the data basically. And that is nothing but compaction. Moving on to snapshot. So snapshot is the number of active snapshots your Iceberg table will have. And it is the snapshot which allows you to time travel. So if I have a snapshot for my previous day, I can go use the time travel query and see my data at that time. But again, I don't want to have too many snapshots because that will um, increase the overhead management of my table. So I can specify how many snapshots I want, or maximum number of snapshot age in terms of days. So that will be automatically deleted at the backend for me. And then the last is the unreferenced file. So if my snapshot is deleted, some of the files which are not relevant to any of the snapshot or the active snapshot, they still stay there, and they are of no use. And that's when your unreferenced file removal job comes in, which basically these files are deleted for you at the backend.
So, if to wrap things up, these are three, at least to wrap that up, these are three new cost drivers for S3 that you didn't have to deal with or think of before these maintenance operations. So there's like, while everything is kind of managed for you, you have to keep your eye on these three things that you didn't have to keep your eye on before with regular S3.
Exactly. If you have your Iceberg on S3, you will see your metadata and data files, but your metadata is basically taking up more space on your data. And then you start looking into, okay, why is this happening? What do I do? And everything, you basically need something at the backend, which with compute capacity basically to run that job, right? And then you spin up like a job, a client to do that compaction job for you. But this is all done automatically with S3 tables now.
Besides those terms, so those are three new, basically cost drivers, or three new maintenance operations you need to keep in mind. What about other new terms? Because for instance, I know table bucket. That's a new term. Not to be confused with the regular bucket, right? So, are there any other terms that even those considering S3 tables looking into it, they should be aware of? Make sure they understand what this thing means and how to use it.
Right. So let's start from the top. So there is table bucket, which is nothing but a resource that allows you to have Iceberg table on S3, and that's table bucket. Another naming convention is namespaces. It is more of like grouping of your actual S3 tables. In simple word, think of it like databases. Database has a collection of table. So is namespaces, which will have collection of S3 tables. The good thing about namespaces is that allows you to efficiently have access control of your data. You can set up permissions over namespaces as well. And inside namespaces, you will have multiple tables. So these tables are basically the S3 tables, which has your underlying data, which are in Parquet format, which are Iceberg format tables. And that's the actual table. And with the inception of S3 tables, what AWS has done is they have, of course, have S3 table endpoint where you can reach out to S3 table endpoint through a VPC connection, and these are regional based. You have S3 tables API, so you can call them programmatically as per your preference. And there is also table ARN. So every table has a unique ARN, Amazon resource name. So it's a unique for each of the table, and you can call them programmatically for your use cases. And also you can set permissions as per the ARN or at table level or at namespace level for your permission control, access control.
I think you gave me an idea to maybe create kind of like a brief or infographic just on these terms and stuff, because it seems like a lot of new stuff, at least terminology to learn. Although namespaces, it's not a new term; it's just used referred to differently, I think, here versus with Kubernetes. But anyways, let's let's kind of dive into performance advantages here. When does it like make sense for a team to switch to S3 tables? What types of workloads benefit most from it?
So let's say you have workloads with common use cases for streaming solutions because there are frequent updates or change data capture where your data is expected to change frequently, and you want that data to also have it at scale, and that's where S3 tables becomes an ideal solution. And it's since it is using Iceberg, so of course your asset transactions, your schema evaluation, everything is supported for you. When compared to a self-managed table with S3 table, your S3 table gives 3 times more performance. And you can expect that, and you can accept 10 times more transaction per seconds when it comes to S3 tables. And that is because the part and parcel it being a fully managed service provided by AWS to you. Other than that, what good thing comes it's of course the S3, the scalability and durability, which has always been there, the famous 11 nines. Simplified security, it gives you seamless integration with other AWS service, and this is very important. So once I have my S3 tables, I can integrate it easily with my other analytics services. That they can be Amazon EMR, Amazon Athena, Redshift. I can even use open source Apache Spark to directly integrate it with my S3 tables. So that is good, and it's fully managed. So your continual table storage maintenance, the Iceberg maintenance, which you spoke about, is done at the backend for you.
So when we talk about the performance of some of those integrated AWS services, something like EMR, if I've got currently a workload that is doing a lot of ETL processing through EMR, I'm taking stuff from an S3 bucket, processing that and spitting it out in maybe a different format or something like that. How much benefit am I going to see from using S3 tables? And is that going to extend to a cost benefit as well? Because at the moment, I might be paying a huge amount in S3 requests back and forth to get the data and put it back again, as well as obviously my storage costs. Is it likely that I'll see cost benefits as well as performance benefits for something like that?
It can so to answer this, I will like to zoom out a bit. So it's because first we need to identify that even the use case need Iceberg format or not. If the answer is straight no, I do not want to use Iceberg, you do not need to use S3 table. As simple as that. But then again, when your use case revolves around constant change data, updates, and things like that, and it is at scale, that is when S3 becomes a good solution. And if that is the case, then yes, because you are calling the S3 APIs specifically to EMR, because EMR has its own file system, EMR FS, that is well integrated with S3. So that gives you added advantages, obviously. But the good thing is, other than that, you can also have a standard Iceberg table, which you, with your own S3 data, not S3 table data, and that can be integrated with EMI as well. The only difference with S3 tables and your own managed Iceberg table is you look after the table maintenance on your own, you look after the storage data on your own when it comes to encryption and other things.
So as always, it's an it depends answer. and we need to get you on the call with the customer I'm thinking of and have a chat about it.
Exactly. An ideal customer, I've worked with a couple of customers, and then they have like a glue catalog table, which is Iceberg table, but then the compaction and everything, which is supported by glue automatically, they have been facing problems with that. And then, we started our discussion around S3 tables and how that can benefit. And we just had a look into what are the APIs, what are the use cases S3 table can help them to, basically maintain the compaction job, the optimization automatically, and just move to S3 tables altogether.
And so, what should like if you're using Glue data catalog tables, what should you actually take into consideration before migrating? You mentioned like it didn't sound like a smooth transition.
Mm-hmm.
It didn't sound like it was just easy to switch. Um, you know, what and even like what operational differences should they expect if they even decide to migrate?
The differences will be negligible. The reason I say that is because you are eventually using the same underlying technology, which is Iceberg. You're using the same data format, which is Parquet. So your API calls are going to be the same. The main difference is that when it comes to Glue data catalog back Iceberg table, you are looking for the table optimization on your own. It can be either done by Glue, it can be either done by you manually, but when we are migrated to S3 tables, that gets done automatically for you. And to answer your question, let's say you have a customer who wants to migrate from Glue data catalog to S3 tables. They can just spin up they can multiple ways. They can use a ETL job, extract the Glue table, load it to S3 table. They can use Spark jobs to load that data. They can use Amazon Athena, as simple as that, to create a table as select, and then import it into S3 catalog. So yeah, there are multiple ways, but depending on the use case, depending on the size of data, uh, you know, um, different approaches will be better.
Sam, you had a question about Athena. I think even before we started recording, was that related to this or just Athena separately that you want to talk to Swapnil about?
No, well, I think actually he's answered my question earlier in saying that if you don't really need Iceberg, then don't use the S3 tables, because the stuff that I was working on was more to do with CloudTrail, which by default doesn't even use Parquet. So you first need to transfer the data from a JSON format into a Parquet format, and then evaluate whether, I mean, yes, the data is changing, that's incoming, but you're not then updating the data. You're only reading it, you're only querying it. So it doesn't really make sense.
That's the reason. The way I will say it is, customers should not try to reinvent the wheel. It's like a new service, a new feature, and come on, let's do that. That shouldn't be approach. It's like, do not reinvent the wheel at all. It's when you have Iceberg tables and you're having a tough time maintaining it, optimizing it. You have to remove that overhead management of Iceberg maintenance, and your table is scaling at a huge size over the time. This is when S3 tables come. It's like S3 is like basically saying, hey, just store your data in S3 tables. Everything is done at the back end for you. But you know your use case that, okay, I'm using Iceberg.
So there you go, Matan. I've actually learned something.
Oh, look at that. That's partially why we host this, is for ourselves to
That's
so
right.
you can come to your customers and take Swapnil's advice and
There you go.
insights and just position them as, yeah, I read everything and
Yeah.
I know this because it's just me.
It wasn't
And,
ChatGPT, it was me.
yeah. um, you mentioned like with the introduction of namespaces, you get like you can set more granular controls around the namespace level. But are there any other new security capabilities, or how does it differ? How does the security model of S3 tables differ in addition to that from traditional S3? Are there any other ways?
So with S3 tables, you can set up permission control at namespace level. So think of it like I'm controlling access at database level. So that is namespace level. I'm controlling access at table level. So I can configure resource-based policies, to bucket level, so to table level or the namespace level. The good thing is that this also integrates with AWS Lake Formation. So when you integrate that with lake formation, you can also have more granular access control, like column level filtering and row level filtering as well. So you are getting into more details, finer details of access control. And of course, you have your AWS IAM integration as any other AWS service for your permissions.
Got it. And I think you wrote a blog post on S3 tables and table buckets, so we'll make sure to include that in our resources as well as like anything about getting started. Do you, I have the link, so I'll include that. But is there anything you want to speak to specifically about getting started with S3 tables that's maybe you want to say here versus just I'll share a link?
I would suggest having because AWS has released a couple of blogs around this, and there's a sample blog as well which is published into it. So just to get started, it's again, it's a managed service. You're not configuring, you're not provisioning anything at the back end. It's simple few clicks and you have a table provision, and you can see the performance, set up benchmark with your data set. It's a interesting take more to understand how your query performance is enhanced. And I, in the blog which I have written, I'm covering S3 tables in Athena and EMR. But of course, you can use various analytics engines. Interesting to see the behavior with Redshift or even like open source Apache Spark.
My last question, and I don't know, Sam, if you have additional ones, but like, does this release change the way that you should look at data architecture in AWS? Does it change anything like that? Any forward-looking implications, or is this not as monumental as I'm making it sound?
I would say no. In terms of anti patterns, let's say, or in terms of your data designing, architecture designing, everything is going to be the same. It is only and only when my client or anyone who are having problems with Iceberg table maintenance, they are having a tough time with Apache Iceberg specifically, or if they are looking for Iceberg offering in a managed way, then S3 table is the solution. Just to let you know, S3 table is, I think, the first cloud object-based offering which gives you built-in support for Iceberg. There is no other cloud storage solutions that gives you built-in storage. So built-in Iceberg support. So that is something very Iceberg specific. So it is very use case specific solution, I will say. There is no anti patterns.
But that's the bit that, I mean, to me, seems like a little bit of an odd release from AWS because it almost seems like maybe a little sleeper release, something they put through and see how people use it, and then figure out maybe, like as you said, it's the first cloud-based Iceberg support, cloud storage based. Maybe it'll become the future trend. Maybe more data formats or maybe engine formats will be supported directly in the storage. That customers don't need to manage that stuff, and we'll sort of see some sort of move away from having to spend so much time doing all those administration tasks and everything else that customers might start, making this one of the biggest services they're using.
Yeah, I'll completely bet on that. The reason being that it's Amazon S3, it's backed by S3. So S3 is well integrated with loads of different cloud providers and different analytics engines and things like that. And it's backed by S3. So you can use the very same APIs at the backend and can be integrated with other analytical service. But as of now, it's completely a new service. It's a new, I think it's just a month old. So as of now, it's very much limited to few of the analytics service. So yeah, but I won't be surprised that the integration keeps on increasing with other solutions.
I remember when Athena was first released and everyone was like, oh, I can just run SQL on my buckets. And obviously with large data sets, it's not that easy, as evidenced by my discussion on CloudTrail for organizations last week, where, I for every day and for every account and for every region, I had to add another partition to my table and I had to manually specify that. And the way that the Athena client works in the console, I couldn't automate that. I had to run a separate query every time and only one query in each window. And it took a long time to find out who was responsible for one specific API request. So I wonder, if this is maybe going in the direction of making things like that easier, making things like, I know there's CloudTrail Lake and stuff like that. There are other solutions for that kind of thing. But for me, as not very good at data, I just want to be able to search stuff. I just want to be able to find the things I'm after. And if this is any help to me doing that, if this is any help to me being able to query data without having to know a lot about it, then that would be amazing. I get the feeling that piece is still a little bit away, but I can always dream.
Yeah, of course. Any final questions? I think this was a pretty concise. I think we covered a lot of the key points, but I don't know. Did I miss anything, Swapnil or Sam? Do you have any final questions? Or you extracted all you need, and now you're gonna go use Swapnil's words as your own? And
No, I'm gonna go and book him
wow.
in his calendar and set up a meeting with my customer.
There you go. Send this episode to them too when it gets.
Yeah, exactly. Or maybe I'll send a raw recording.
Yeah,
All right.
You have covered pretty much. Yeah.
Cool. Well, thanks for listening, everyone. We'll see you in the next episode. Let us know if there's any topics we should cover, if there's anything we should go deeper into. And
Don't
see you
forget
next
to
time.
check out Swapnil's blogs on the links.
Yeah. We'll include all the relevant links in our post, in our in the resources and whatnot. Bye.
Thanks all.
Bye,
guys.
Put that bye in there. Just kidding. Bye. Why did I even say that?